I definitely. Hi, so good afternoon, everyone. Welcome back to this session. Afternoon sessions are going to be leading sessions. So I'll ask every participant to participate actively so that we can have an interactive discussion. If you have any queries, you can interrupt me at any point and let me know the same. So in this particular session, I shall be dividing into four parts. In the first part, we shall be seeing the particular material image processing, how to bring in any stack of images or the industrial image data set that we work on, the raw images, how to do the image processing of the same, and followed to that, we will see the finite element modeling and the modeling capabilities in simple way. After that, we shall be also seeing the measurement section. What are the different reporting tools that are available? And at the last, we'll see the 3D printing tools that are present in the software. So, without wasting much time, let me start. I'm just sharing my screen. I hope my screen is visible. So, I'm just opening Simple software. So this one being a medical version, but it has the same features as of the research bundle, so we can do the image processing, whatever image type that we require for. Let me take an example of a log diagram dataset that was worked in the IT routine. So they have this particular IT, the geoengineering section where they first do the image processing of the sample, then do the finite element analysis to check the particular qualitative analysis as well as the quantitative analysis of whichever log they are working on. So to open the folder, I have the log diagram files. I'll just select. These are basically diagram files. It is a CT image, but still they are taken as a diagram images because they are basically used for non-destructive evaluation. The process is same as we do for the diagram, but there's a slight difference when we will be doing the import. Currently, till now we have seen the data that we usually take is around 46 MB, 50 MB, 20 MB. It's under 100 MB generally when we are importing the data set. But now you'll see how it is, how the software is working and when the data set size is quite large. You can see the number of frames are around 945. So it has 945 slices of image. It is a complete rock sample that was taken. It's a CT was done. Once a particular CT was done, we can just click on finish. We have imported the particular CT file of this rock. And this rock is just one example. Even if we have any composite material, we need to check for its properties, the different constituents in the material. We can come over here, we can do the particular analysis, and we can have the most accurate and the most precise result for us. Now, coming back to this image, once it has imported, although it is written as coronal keratitis and axial, since this is the medical version of the software that I am currently focusing the live demonstration on. Just a really question. Yeah. So, pardon for the listeners. Uh, Over the left-hand section, we have the spacing information. Over here, you will see the spacing is quite minimal. It's around 0.04587 millimeters of spacing. So, why it is done for such rock samples? Because to identify each and every small feature, if the particular slice thickness would be around zero point 0.4 mm, which is considered a good value for medical cases, but not for any rock or for any composite material, because the small features are the hidden points. So this particular rock analysis was done to identify the region which carries the particular oil constituent in it. So it's how much more important for us to identify the regions which is carrying essential minerals in the particular rock sample, oil content in the rock sample. So that's why we have kept the particular spacing, that is the slice thickness, as minimal as possible. Once it is done, we have obtained the three views, but you will still say that it is looking like a cuboid, and we are unable to see the particular volume rendering of the rock in the 3D view. So no worries for that. What we need to do is we need to click on this particular tab named as Configure the Background Volume Rendering. This we have also seen yesterday for the medical dataset cases where we can use the bone dataset, where we have used it for soft tissue dataset. But now, let me show the magic how we can operate it for a particular rock sample. So we can have an option as maximum intensity projection followed by rainbow. It tells us the best view of the particular data set that we can make. Here we can set out the points corresponding to which we can have a much more proper visualization of the same data set. So even if there are small constituents within this rock sample, we can easily identify it. We can highlight the different region. We can intensify the particular sample part. So like this, various properties can be enabled. We can enable the shading to have a much more greater and proper visualization. So now you'll see the particular data is much more clear, and we can have a perspective how the rock sample is looking in the particular city scale. Now, we also have other options. For example, if we need to change the color to have the outer surface analysis, what we can do is we can just select an MIP rainbow, and here we can see how the particular rock sample would look. We can increase the intensity, we can increase the point, reduce it down the value over here to have a solidified version of the rock. So we can set the grayscale here, and we can just highlight the particular rock sample out. Here we can also change the mode. So minimum intensity won't show us anything. Additive one will show how it is varying from the particular background, but it will also highlight the background region. So a better approach is always to use the maximum intensity or a composite one, because a composite will show us the whole structure. So even if we need to see the fracture analysis of rock, what are the particular weak points in this rock, we can do in a very easy and efficient way. This being the volume rendering. Now coming on to the image segmentation. As I told yesterday, that we have certain methods to do the segmentation. For rocks, we don't have fully automated segmentation, but we have one sort of fully automated segmentation that we can work on. How to do that? We need to go in the multi-level auto segmentation. Here, whatever number of masks that we set out, we can write in, and it will do a thorough auto segmentation for us. It takes the variation of grayscale value in mind. How the particular variation takes place, let me open a threshold to explain out the same. Currently, what we can observe is there are total two peaks over here. Whenever there is a peak, there is a material change. So, for example, let me just zoom in out. I'll keep this particular part clicking on apply. So I have taken the lower value as 0 and the upper value as 12,763. And you will see that it will have a grayscale value around 65,565. I also don't remember the exact value, just see right now once this particular process is completed. Why this is? Because it takes the particular data as an 8-bit data integer format, and it sets out the color coding of grayscale value accordingly. That's right. So let us check what is the format. Yeah, so it's 65,535. It's not 565. I was losing track, but it's okay. So this way we can highlight one region. Now we can also highlight the other region. Why we have done this? We just need to separate out the raw sample from the existing uh, whole sample that we were having. Once we have done this, we just need to click on apply. And now, since our majority of work revolves around this particular blue region, that is the rock sample, and in the case of material, this being the material part, for example, any composite material that we are working, any alloys that we are working, we need to do the reverse engineering processing that can be carried out. Now, coming back to this part, since my interest area is this master, so what I'll do is I'll just hover over here. Then I'll isolate that part out, generate a fast preview. Yeah. Once a fast preview is generated, we can now see a clear example of this particular rock sample. We can examine each and every point, each and every point corresponding to the curvature, and then we can operate the same. Also, you will see that it is the dataset memory size is increased to around 1200 MB. So it's around 1.2 GB of dataset. And it is generally recommended to have the RAM size into 8 to 16 times as that of the English dataset that we are working on. So current RAM requirement would be around 10 GB to 20 GB. So whenever we will do any sort of processing. So what we do instead is we can work on two principles. Either we can have a decent workstation to do the segmentation part first, or what we do is we can do the part-wise segmentation or part-wise splitting of the region. For example, I can take this particular part out. I can check for a smaller value. I have taken a very small value of this particular rock sector. Why I have done so? So as to validate my result, I can take a small part, do the segmentation over it, and once the particular segmentation and once the segmentation is performed, I can also perform the same sort of scripting options for the whole big sample without the GUI. So the memory utilization gets decreased. How to do that? Once we have done this, we need to go in the scripting section, and here we have an option of record. So now whatever step I'll be doing after this particular step, it will take the consideration, it will take into consideration whatever operations I am performing. It will record out a script for the same so that I can repeat the same script for a larger sample. Now, coming back to the segmentation part, since now we can see there are multiple peaks that can be observed in this sample data set. And we were told that particular uh, rock sample had three parts, that is the solid rock, then the oil content, and the air content, aerated content. So to do that, what we do is we go into multi-level auto segmentation. We set out the number of masks. Clicking on apply, sorry, we set out the value as 3, clicking on apply, and it has identified different region. So what it does is it identifies the region with minimal uh, grayscale value. So the green region that we can see right now is the particular oil content in this sample data set. The particular uh, white the blue region that we can see is the aerated content, and the red region that we can see is the rock sample. So it depends on the density of the different constituents that are present in the material. So what we can do is we can rename it as oil, and we can rename it as air, and then we can rename it as rock. Yeah, so once this particular sampling is done, we have obtained a particular resolution. Our next task revolves around to do any type of simulation, like a finite element analysis if we need to check for a fracture, or if we need to check the fluid flow of any rock or any other of oil or any other fluid in this particular rock sample, we can also generate a CFD analysis for a solid material. How to do that? We can just drag and drop this particular part out into the model section, and we have the same depth that is obtained. So this is now we are coming on to the FE modeling option, how to do the FE modeling for a multi-scale material and for a multi-scale modeling material, how to do the FE modeling. Once we open this particular tab, surface model, we go over to the setup model. Now, since our requirement relies on a FE model generation, so what we'll do is we will go over here and for example, if I am quite familiar with LS Liner, I'll just select with LS Liner and it will manage our all the particular tabs according to LS Liner software where we can do the particular modeling accordingly. So for example, I am selecting this particular part as volume meshing. Here, I have selected all the particular samples. Now, since I was much more interested in the oil sample, so I'll increase the coarseness level. I can also increase the coarseness level of here so that the level of accuracy becomes much higher. I can decrease the coarseness of rock because it is the major content in this particular sample. Now, in the material settings, if we are familiar with the Young's models and Poisson's ratio of the material, we can set it out individually. So once we have set out the ABC value, insert in the Young's models formula, we can find out the exact values. Corresponding to value, we can set out the material property. Same can be done for air. We can have a different material types. Let's say, for example, selecting minus 226, then 1.2 is power 10 and C is 2. And A being 0.5. See, I can take it just 5 pixels to the road for us, taking over here, setting out the property. Similarly, we can have the grayscale value based property set for the row also. Once that is done, we move on to the next part, being the addition option of all the possible contact fields. But before that, let us again come back to this volume meshing. This was just a coarseness, and one might ask, it is a very, it looks like a very basic tool. We are just setting the algorithm according to our requirement. We are just setting the math and stick, but it is not just that. We have other options for advanced user. For example, we can go over this more options settings, and over here, we can select the additional mesh quality improvement. We can enable it, we can disable it. Then we can also select the quality metric type as tetrahedral volume skew, tetrahedral minimum dihedral angle, Jacobian in and out ratio, and edge length ratio can also be set. So we can select out different methods. We can set the smallest element improvement. We can enable that part out, and then we can set the characteristic length target or the limit of maximum displacement that we are required. Here also, if we are requiring to snap it to a parent surface, if we are working on any surface object, that too can be done. Also, whenever we are setting this point, so we can also add set the particular settings each and for each and individually for all the particular elements that are present. So we get a very high and very high quality mesh for all the particular samples. Now coming on to the next part is the addition of all contact pairs. So we have two options. Either we can go with a direct approach, we can add all the particular possible contact pairs, removing the unnecessary one, like the boundary conditions one, if they are not required, we can just set out a particular contact pair points for them. But for example, if I am much more interested in the specific region that is connecting the rock with, sorry, the oil content with the air content, so what I can do is I'll just go over here at the end in menu selection. Now I'm given with three sets of options. Either I can use a custom based approach, I can use a primitive shape approach, or I can just select out the mask around which we need to select out our region of interest. For example, using a basic custom, I'll just select a particular part out, and it will develop a custom for me for the same. We can just check out over here how the piston is looking. Once it is done, if we are satisfied, we can just click on done. Now, if I add all the particular possible contact pairs, we have also given the additional option of the region of interest that we have selected. So we remove the non-required parts. And now, for example, if we are requiring the region of interest between oil and rock, we can do it, and if we need to remove it, we can do it like this. Once that is done, we move on to the next point. If we need to add the sets, we can do it like this. We can select, for example, the region of interest that we have already selected. We can also set the particular type of the nodes. And then once we add the particular, all the particular nodes that are connected to the specific part that we have segmented out will get selected. Next up is the possible addition of all the particular shell points. It's again being the same as we do it for any contact point sets, any set point set. So this all can be done. Similarly, is the boundary layer typing style. Then that was told yesterday also how to set out the boundary layers, how to set out the slicing. So these are the basic process that needs to be completed. Once that is done, we just need to click on model preview to check if there are any sort of deformities which might distort our results once we have completed the simulation. So we can go in this model preview section and we can just then go to the segmentation quality to check out how the output would look once we have solidified it, once we have done the particular processing part. Since no segmentation problem is found, we can move on to the full model generation. Since this is a three-part material, it will generally take around 10 to 15 minutes for a 16 MB dataset to work on. When the dataset increases, so would be our computation time. But I have already computed some of the results for the same set of samples, so I'm just cancelling this out. So it is the same block sample that we were working. I have done the minimalization of the data set. It was some for the upper part of the block sample where we have distinguished different regions. So this was the mask that was captured. And here now we are working. So what we'll do is we'll just once our particular model is developed, we can go over here and a full model can be selected out. We can just click over here. It will start doing the mesh generation since it is already processed once in the past. So it will generally give us output at a much more greater and a faster rate. Now, this being said, we after the particular FE modeling, whatever output is produced, we can just click on export. We can export out the file, save the file, run in the particular simulation software. So how to run in the particular simulation software? Let me open it again. We need to go into help section. For example, if you aren't familiar with Abacus, so what I can do is I can just select Abacus CE and it tells that we can directly import the .inp file that is created and we can run the simulation. Similarly, all the other software, how to run it on NSYS workbench, how to set out the files, how to set out the condition. Similar for Alistair, OpenFOAM, how to work it accordingly, console, how to use the particular file. We can check it over here and we can directly run the simulation on our simulation based software. Meanwhile, let the particular task be completed in the background. I'll again take the example of pelvis. Why? Since we were working on it yesterday, we were developing on the FE model. We have worked on the particular FE model development. But to show in detail what are the additional measurement tools, what are the 3D printing tools that are available, let me take the same example. Since I had already segmented that particular part out, I'll go in the program file section. Over here, we have the synopsis folder and the medical folder going in the data section. We'll just open the file that we have already done the segmentation for. Once this particular file is being loaded, I'll just wait and wait for the operation to be completed. Once it is completed, we have got the segmented result for us. Now, for example, I am just generating out a finite element model for a pelvic region. I have also included the sacrum part in the small photograph from save. But since we are only working on a pelvis, I will just isolate this part out. If I need to do the finite element analysis over here, I need to check the weaker points over this polygon section. We'll just mark it up, mark up the boundaries, and the next part revolves around. So, just give me. Yeah, so the next part revolves around to just drag and drop the part that we need to model. We click over here, we set out the properties. The tab is almost same for either for the material manufacturing, material paper, machinery, or even if we are dealing with any biomedical data set. So the process is quite same. But since we have shown the FA model and it is being developed, so that is run in the background. Meanwhile, I can show for the node model to how to do the particular nurse modelization, how to do the fixation. The part is already smooth, so we don't require to do the smoothing again. Here in the surface settings, we are given the two sets of operation. Either we can select it, use triangle smoothing for mask, or we can use triangle smoothing for surface object. Since this is a mask, so this option is selected. And now coming on to the nerve splitting. Here we are given with some options that we can select out for. For example, here we can select the target patch count. If we need to reduce it down, we can select it over here. If we need to reduce down the angle, or we need to do the feature alignment property. So what we can use? We can use on the value. And if we are having any surface file, so we can also click on this snap patches to parent surface. Here we have the two formats, IGS and STEP. Both are the advanced formats for CAD file support. Once that is done, we can just go on the click on the full model resolution. It won't take much time. It takes around 2 to 3 minutes for the full model to be completed. Once the particular finite element, once the particular non-information is then switched upon the list generated, we can check out the surface quality, we can check for any deformities and other optional features that we are seeking for. That is saved. So it will also get completed in next 2 to 3 minutes. So So it uses automated patch fixing for generation of different patches on the polygon shape patches that it will generate on this particular LB section. And here, any curve surface that you're working on, right wing in any manufacturing part, or any other bone, for example, the shoulder bone or the sternum, if we need to work on, femur we need to work on, we can produce high quality CAD files for the same and that is that can be generally used and imported in any of the CAD modeling software. And then we can check for the integration. And ultimately, if we need to do the remeshing in any analysis software, we can do that in a fraction of seconds. So it is done. It took around 1.5 minutes for the particular nerve surface to be generated. Now it does the final part that is it is fitting the nerve surface on the existing mask that we have worked on. It will take another 30 seconds, 40 seconds for the process to be completed. Once the particular process is completed, we'll be having our nerve structure. Meanwhile, this process is also around 75% complete. Let the particular process take place, and once it is done, we shall be having our nerve. Now, related to the computational fluid dynamics, I'm not explaining the CFD part as of now because that would be covered in the tomorrow's session because tomorrow's session is majorly focused on the soft tissue segmentation and the vascular simulation. So vascular structure and soft tissue simulation generally have the most common application areas for computational fluid dynamics in terms of biomedical and biomechanical analysis. So that part will be covered tomorrow. But to show how a fluid flow analysis would take place in solid, I'll just cover out that part right now. And after this, we shall be moving on to the measurement part, followed by the 3D printing section. So let the process be complete. It will take just 30 more seconds. Meanwhile, if someone has any queries in between, they can let me know. So it can be an interactive session. Yeah, any queries, anyone? Okay, so I think there are no queries as of now, but let this process be completed. Now patches, let the now patch be generated. Meanwhile, let me load one more window of simple way to start showing the measurement part. Again, opening the same folder. Now, to show the particular measurement, let me take an example from an auto segmentation project. So I'll just open the required file. It's somewhere around here. Yeah, so it's around here. So I have already submitted a couple of files for using the auto segmentation. So let me open the auto segmentation offer. Yeah. So coming back to the measurement part, what we have is we have multiple options. And the measurement, we can go in the measurement tab, and here all the particular important sections can be opened out, different parts can be identified, and we can do and carry out the segmentation accordingly. Over here, all the particular possible points as explained in the auto-fitted segmentation gets displayed. Yesterday, we have shown how we can do a line-to-line measurement. Even if we need to do an angle measurement, so for example, if we need to carry out the angle measurement of a cubic car, that can be done in a very easy way. We just need to click over here in the create angle measurement. We can select out the points corresponding to which they are required to generate the angle measurement for, and the angle comes out to be around 25 degrees. Uh, So this way, if we are required to do any angle measurement, we can do that. Apart from that, we are also given with additional tools supported for doing the measurement. First of all is the 2D contours. Whenever we will be clicking on 2D contours, we can be drawing out the shapes within our segmented tab. So for example, if I need to do the 2D view measurement of this particular uh, item, what I'll do is I'll select out multiple control points along around the particular surface, or I need to do the 2D contour measurement. So the more number of points will ultimately lead to the higher accuracy as desired by us. Once this is done, we can see over here. I'll just zoom in the particular section. Since it works on a 2D contour, so I can also manipulate the points over here. I can also increase the point to have more control over my control points, like this, redefining our shape by a little bit. And this way, we can get the accurate measurement. So it tells out corresponding to whole surface, what's the total perimeter, what's the in-circle diameter, what's the out-circle diameter, the TT distance, the posterior perimeter, all gets disclosed over here. Apart from it, we are also accompanied by various volumetric settings. So, for example, if we just need to check out the volume from the 3D view, I can just select off the part. If I require it for spectrum, I can just select it, and it tells us a particular voxel volume of the same. So, if I just click on voxel, I can just check out the voxel volume of the same. Similarly, I can select for any part out and we can see it from here. So the accuracy is quite high. Apart from this, if you need to generate the statistic of whole mass, I can just click on generate statistics over here, loading the template. Once the template has been loaded, we can work and we can have all the particular values being displayed in a singular tab, which can be later on exported out for the reports part. Now, if we need to export a particular file to SolidWorks, we can just click on this export button, enter design module tab, and we can export out the particular design that we're working. Next up is the option of center line. For example, center line measurement plays a crucial role specifically in the vestibular calculation. Just to show how it can play a good role in the orthopedics one, let me isolate this part out. Once the particular part has been isolated, we will just click on create. It will take around 1 minute to create the center line for the whole module. Once the center line has been created out, I can zoom in the structure, and then we can go to this cross section measurement. Now, corresponding to any point that we will be selecting, we will be taking the value of the cross sections, the points coordinates of the particular point that we have selected, the plane normal value of the plane around which the particular cross section has been measured for, the area corresponding to this cross section. Then we can also check for the particular perimeter, best fit circle, prescribed circle, and all the quick statistical information that I generally relied using the center line. Apart from it, if we need to do quick line statistics, this is also one good way of doing measurement. We can go over here. We can select the path that we need to basically measure. For example, if I am working on this particular center line and I need to check corresponding to this center line, we have the maximum cross section area or minimum cross section area. We just need to click on this compute tab. We can just select maximum cross section area, minimum cross section area. Also, we will also get a mean value of all the cross section areas over here. Apart from it, we can also color out all the particular cross sections that are present. We can also color the lines, different lines that are present, and we can have the most precise of calculation for any structure that we are working. Over the right hand side, we get a bar of the same corresponding to the length of the center lines that we are having and we are using. Apart from it, we are also given with an option of checking the wall thickness. So we are given with two sets of algorithm. Either we can use a ray casting or spear fitting. Our ray casting is a better preferential because the spear fitting is generally used for curved surfaces. In this case, it can be used, but generally we prefer the ray casting algorithm to do the particular measurement. On the right hand tab, we check out the wall thickness, the minimum wall thickness being 1.276 mm and the uppermost wall thickness being 108 mm. We can also annotate minimum and maximum enable grouping. So we can check the minimum wall thickness is around here, 1.276 mm, and maximum wall thickness is around here, 108 mm. This way we can check for the wall thickness too. Now comes in the next part, the report generation. So let us obtain any finite element model. So for example, let me take this particular sample and generate a quick FE model. I use a FE method for a faster calculation. So FE grid method is generally faster as compared to the FE method when we are coming and talking in terms of the simulation task. So we can just select out the FE grid method, completing the simulation. Once the simulation is completed, we can go over the report section to generate a detailed report of whatever calculation or whatever analysis that we are performing on. So this way, this particular part of measurement gets completed, and once this particular part gets over, the next part is the 3D printing, how to develop a 3D printed model, how to follow up a structure, clip different surfaces. I'll also just turn on my camera after this part to show how we have worked on a cardiac sample, in which we have done the particular 3D model preparation for a VST set and how to simulation of cost and policy. Or else I can show that in tomorrow's session so that we can have a better clarity about how the particular field applications of in the case of cardiovascular work. So my colleague Pratik will show in tomorrow's session how a particular cardiac segmentation has is performed and how we are using it for the practical application by generating a 3D printing output from the same. So that this particular process to complete. Let us check uh, who is our progress over here. So it's taking some amount of time for the process to be completed. Let us wait for the outcome. Meanwhile, one more thing I can do is instead of going for a larger structure over here, we can also show for the particular premium part how we can generate out the report for the C. Now, taking the example over here, it's just evaluating the mesh quality once this particular mesh quality is evaluated. We can check the mesh quality over here if there are any sort of errors that are present in the data set. So the particular FA modeling is completed, and we can see how fine of a mesh the software has created that can be completely relied on. So for the surface that didn't require a final mesh, so it has automatically selected the particular parts. And for the areas where the particular meshing was required, nothing complex, so it has designed it accordingly. Once it is done, we can also check the mesh quality from here. So we do have an option of checking out the mesh quality of any part that we have developed a finite element model for. Once it is done, we move on to the next part in the measurement only to generate out a report. Also, we have some part coverage in the analysis section where we can check on the same. So here we can see a graph between Jacobian versus frequency of the material. Here, as one into this, there are no warnings, no errors, so the particular surface mesh quality is quite accurate and quite precise. Now, coming in this report section, since we have an option of generating a particular multi-level mass report, we need to import other left humor or to right humor also to generate the particular multi-part report. But to generate for a single part object, what we can do is we can just click over here, generate a multi-part report of this singular object, and report would get generated in a quick time within fraction of second. When this particular task is completed, we move on to the next part in which we highlight the different regions that are being present. We can do, or we can also carry out the particle analysis. We can also do the particular core analysis in a much more detailed and a much more efficient way because FE model generally produces a better result as compared to particular normal volumetric file that we are using. I just closed down the process because it was taking much more time for computation. So once it is completed, we just need to drag and drop this particular section over the analysis and we can carry out a semi-FE analysis for this. This is how once our report is generated, we can check out the report over here. We can also populate this particular graphs. We can do the particular markings. We can draw the different angles. Or we can also import the volume distribution directly from the calculated result. We also have additional options to add or edit nodes. For example, actually, FA or genetic in this setting. So we can see whatever nodes we need to type, we can check over here. Where is the data, author's name, everything gets recorded over here. The model type that we have exported to the volumetric count, the volumetric fraction, the whole part is contained. All can be displayed over here. Now, when I drag and drop into this analysis section, and if I need to do a particle analysis or a detailed code analysis, you can just look over here, you can and then I can just run analysis and then map to mesh will just map the particular pores corresponding to the mesh that we have selected. So we can have a better approach and a better output when we are doing the mapping of the pores that are present in the particular mesh file that is being created. So it takes around 30 to 40 seconds for the process to be completed. And once this process is completed, I can directly see out the results. Apart from that, we can also do the full initialization from here and check out if there are any surface deformities that are being present. So here we go, we check out the particular part, like it complete, it will take another 2 seconds for the process to be completed. Once it is done, we just click on this map to mesh for the further process. Meanwhile, coming back to the 3D printing part, since it's taking a little more time. In the 3D printing, we have a better approach to deal with any object. For example, if I require to have the 3D printing done of both hip right and hip left, and there is a gap between these two parts, and I need to have it as a single surface. So what I'll do is I'll go into the surface tools option. Here we have an option of mask to surface. We select the particular part that we need to generate a surface out for. Before that, we need to always generate a path to for the particular 3D view to be cleared out. Once that is done, now our 3D printing tool tab gets activated. How? So we just need to go over here. Now, in the 3D printing, we have two sets of options. Either we can directly select the surface, we can set out all the particular possible connectors between the surface, so we can have a single object. Also, one more thing that we can do is we can increase the pad size uh, over this direction. So we'll just click over here from padding. I'll increase in the vertical direction by 10 pixels. Yeah, I'll increase a little bit more, so around to 30 more to satisfy my requirement. So why I have done this is we also have certain other approach like a primitive to create a primitive base structure for it over this particular 3D printing that can be created on. To do so, we need to go the surface tool option. Here we have an option of create primitive. Here we can select the shape of primitive, and then we have to consider multiple options to set out a primitive for. Either we can select the particular points in the view. So, for example, clicking the point in this view or this view will start. We need to just click a particular region over which recently deleted. Again, starting this, selecting out the piece. For example, I'm taking this much part. Now, the base is set, but what we need to do is we need to reduce on the edge length in the other direction. So what we'll do is I'll go over here, write it as 5. Here also I'll write it as 5. So here I'll write it as 5 and here I'm writing it as 5. Yeah, once it is done, I'll just push it over here, increase the base size also, and whatever part is behind this, we can directly remove while we do 3D painting. So we just need to click on create primitive and it will basically add a different structure over above part that we were working on. Once this is done, what we need to do is we need to go over here and now we can add different connectors to have a base for our 3D printing. So before that, what I'll do is I'll just select out a plane corresponding to which I need to cut out the surface. This is a proper plane corresponding to which I can cut the surface for. Going into advanced option, I just skip out the particular surface, selecting the plane. Once this particular plane is selected, partitioning that out, and then this part can be easily removed. Now we have the desired part, we have the desired operation. So why we have created this structure? So we need to have a place for the doing the 3D printing on the same. Now, when we are doing the 3D printing, we need to go in the 3D printing tab. Here we can select the option of create connectors. We can select out the surface corresponding to which we need to create a connector. So first I'll take a cuboid base at the hip right base. Here we have an option of automatically adding the particular connectors that we require just by clicking generate. Yeah, so I'll just select the other option, center to center, and we can basically generate the connectors. Before that, I can also prune all the particular center line that are present. I'll go in the center line option. I'll just delete this particular part out, all the particular center lines that are present. Yeah, once this is done, I can again come back to the 3D printing part, clicking on create connectors. Now adding the surface. So for example, this to the keyboard. I can have all the particular possible connector points that are required. Similarly, I can select the hip right keyboard, and again I have the particular possible connectors. And now connectors between hip right and hip left. So this is the best way and the best approach to mark out the connectors while we are doing the 3D printing. Apart from it, we are also given with additional options such as if we need to do the import steps, we can do that. Once it is done and we are satisfied, we just need to click on create and you can see all the creators are connected over here. We can combine all the connectors as one single object while we are doing the 3D printing that can be used done using the Boolean operation. Now, if we need to emboss any text on the surface, for example, if I need to write a pelvis or since it is a pelvicity data set for which we have done the scanning for, I'll just click on pelvis. Now I need to select out the active surface on which I need to place the particular word code. Clicking over here, you can just emboss or emboss the surface. Once it is done, you can see in a small letters it has written pelvis. I can also increase the font size to 120, generating the same. I can rotate it on this particular axis. Yeah. So like this, we can also emboss the text on any surface while we are doing 3D printing. So it provides a complete uh, toolkit for us. Apart, once this is done, if we need to do the color proofing, if we need to have a printed structure generation, we can set out the color coding and we can start the printing. We can also check the printability of the same carrying out here. We can we can see corresponding to which point we have the least wall thickness and corresponding to which point we have the greater wall thickness. Since this particular part requires some fixation, what it will do is we'll go in the check and fix option. It will check the surface quality and correspond to whichever point there is a surface error that is to be found. It will automatically try to fix that up. Once it is done, we can see all the particular possible points. We just need to click on the fix surface. And it is not just depending on this particular data set. Even if we are working on any other similar workplace, we can do the same for any SQL file, for any CAD file, even if it is not designed up in simple way, then to the particular task is done. We'll also see the particular part respond to which it is done. Once it is done, we have generated a fast figure of the thing. Now what I'll do is we can just go to this option, export scene to disk, and then we can select out the file type for doing the 3D printing. PMF can be selected STL, OBJ, PLY, 3D PDF, and VRML. Apart from this, in the 3D printing only, we are given with option of generation of cutting guide. So surgeon can also create their own surgical cutting guide directly. We just need to select over here, mark up the region. Now we need to select the surface for which we need to create the guide for. Since this being the hip guide, over which I require, I just need to click on cutting guide. I can set out multiple planes along which we need to create a cutting guide for example, setting a cutting guide over this plane. We can see the plane that it has selected. Once it has selected the planes, we can set out the pin center holes, setting out the full radius, wall width, and height accordingly. For example, if I need to reduce of the height to 1 millimeter, I can do it like this. Wall width also can be set accordingly, and then we can add up the different points. So you can check it over here. Once it is done, we can set out the piece. We need to increase the brush size by it amounts to 11 brush size or 7, 8 is fine or surface. So even if we are having any complex surface and we need to create a cutting guide for that too. So that too can be carried out. Once it is done, we can check the preview or we can also save the surface, seeing how the cutting guide looks like. You just create the account, generate the surface. So It takes around 1 minute to generate out the surface. Once it's done, we just need to click on create surface and it will create the additional cutting guide that was desired for. Now, this was the part that was to discuss. The finite element characteristics have been also discussed over there. We have the option of mapping machine. We can select the volume nice approach, and then we can generate a CSV file for the same. We can also do a full visualization. We can see that in a color scheme too. So there are different options that we can finally conclude out of the result. Statistic, we can generate any types of statistic, and the results can be further exported out. So this is how the different FE modeling feature works, the 3D printing feature works, and the measurement feature works. Just being all for today's session. If anyone has any query, they can let me know. In tomorrow's session, we shall be discussing about the particular soft user segmentation, SQL segmentation, followed by the particular CFD analysis of the same. So I'm now opening the session for question and answer. Kindly raise your queries over here. Yeah. So does anyone has any specific query related to any part or any tool? You can let me. Are there any queries? If not, then I think we can conclude the session. I'll request everyone to join for tomorrow's session. Meanwhile, if there are any further more queries, you can also contact me over my WhatsApp or my calling number and just sharing in the chat box followed by my mail ID. So I thank everyone for joining this session. See you tomorrow then.